To be honest, as a kid, I was actually terrified of these things. There was a book that came out by a guy named Whitley Strieber, and it had this gray creature with these giant black eyes. And he tells this horror story about being kidnapped and taken into a spaceship and not to be gross, but getting an anal probe. And I remember being like a friggin' 12-year-old thinking, this sounds horrifying, and really becoming strangely interested in the topic because I just wanted something that would tell me this wasn't possible, this wasn't real. And for years, I would listen to physicists who would essentially say, like, listen, the universe is massive, and there's a gazillion, trillion, bajillion galaxies, and they have a gazillion, trillion, bajillion stars. And those stars, X amount of those gazillion, bajillion have planets, and X amount of those can hold life. So yeah, there's probably a freaking ton of life out there in the universe, but they'll never get to us, so don't worry. There's no way that they could survive the travel. They'd have to go faster than the speed of light. It would take thousands of years. They could never survive it. This, that, the other. The physics won't work. And I lived very comfortably under that assumption until you. So how, if these things are here, I watched the documentary and I listened to different physicists posit a guess, but it was a bit confusing. How in the world do we think these things could get here from such a extreme distance?
Sure, and that's a great question. You're referring to earlier about the Drake equation, and that is the
Yes.
statistical likelihood
Yes.
whether or not intelligent life exists in our cosmos. And there's actually a very interesting equation that kind of goes into that. And in fact, the Pentagon actually paid for a study to look at the Drake equation and to reconsider the potential statistics if whether or not it's either more likely or less likely. The reality is we do. We live in an incomprehensibly large universe. And in fact, right now, a lot of astrophysicists have surmised that there are over 200 sextillion
Oh my
stars
gosh.
in the observable universe. Now, what is a sextillion? I don't know, but it's been
Wow.
estimated that there are, to put this in more common parlance, it's been estimated that there are more stars in the visible universe than there are grains of sand in all the beaches of all the world, right? And that's just the observable universe limited by the horizon of light reaching our planet. And a lot of scientists now speculate the universe could be at least 10 times actually larger than that, right? So 40 billion light years from end to end, and that's just the visible universe. So it is a comprehensively large space. But I've also like to remind people, if you've ever taken, oh, I don't know, maybe high school chemistry, Avogadro's number, right? One times or 6.82 times 10 to the negative 23rd or something like that. The reality is, if you were to compare the size of a quark to the size of a human, that's roughly plus or minus the same order of magnitude, the if you will, as comparing a human being to the size of the known universe, right? It's we have an equal amount of space in scale inside every single human being. And we as human beings really we can only interact with one or two orders of magnitude up or down. Otherwise, the universe is simply too big or too small. We'll never be able to actually interact with it directly. And yet that is where most of reality actually exists. So if you were to consider, for example, you asked a question about the vastness of space.
Yeah.
The old models of physics dictate that there is this speed limit in the universe called the speed of light. And how
Right.
fast is that? It's roughly 186,000 miles per second, or roughly 7.5 times around our planet in 1 second. So it's very, very fast. And yet, because the universe is so incomprehensibly large, it still takes 40 billion years for a photon of light to go from one end to the other, right? But we're now realizing, with the understanding of the theory of relativity introduced by Einstein, and of course, in the 1930s, the introduction of quantum physics, that there may be some loopholes in the laws of physics, and not necessarily in the speed of light, but in the notion of space itself. Now, this is going to get kind of weird really quickly, but scientists now realize, and you can look at other experiments involving quantum entanglement, that space, the way we experience space three-dimensionally, and as being kind of this empty vacuum of nothingness, in reality is full of stuff, and it's also a bit more like Swiss cheese. There's holes in it, and if you want proof that these holes exist, one only has to look at a black hole. There's a lot of studies being done right now. A lot of money is being put into studying black holes where matter goes in but never comes out.
Right.
And it may be that the gravity itself is so severe in these localized regions, what we call black holes, that space and time actually folds in on itself. And that there are ways where you can traverse vast distances within our cosmos without really going very far at all. These concepts are called wormholes, and believe it or not, once again, your taxpayer dollars paid for extensive studies back in the 2011 timeframe at the Pentagon, at the CIA, and some renowned academic institutions that actually was very seriously considering the viability of wormholes and the ability to engineer, if you will, space and time.
All right, guys, if you like this clip and you want to watch the full episode, click here. And if you want more content like this, you can subscribe to the show by clicking here.